This problem is asking how many triangles are possible given the information where you have a side-side angle situation. It's part of what we can call the ambiguous case, where you can have a couple of sides and an angle, and there's possibilities that can happen. Either this will result in one triangle. It's possible that a side-side angle situation can result in two triangles, and it's also possible it could be no triangles. I don't like this picture over here. If they're talking about A being a 20-degree angle, I think this picture makes it a confusing problem. Yeah, they're just saying general triangle. I understand that, but I don't think it helps students that are trying to learn this. This triangle, this angle looks like at least 45 degrees, much bigger than a 20-degree angle. So I'm going to suggest that we look at this problem from a drawing standpoint and see, if we were to draw this out, what would we be able to get some information? And the answer is yes, you would. So let me get to a screen that I can draw this out. They said A is equal to 8, B is equal to 5, and they said angle A is equal to 20 degrees. I said I didn't like this picture because that angle is more than 45. So what I'm going to do is I'm going to start by drawing what I think is a better idea of a 20-degree angle. Now I know this is not 100% accurate. Might be a little less than 20. But it's a lot closer than 20. It's a lot closer to a 20-degree angle than it is to the angle they showed. And it's important to draw somewhat. If you've got a protractor, that's probably a good idea. It could help you do this. But I'm drawing a pretty decent representation of a 20-degree angle, and I did kind of freehand it, but that's okay. It says that you have a side of size 8. Side A is 8, and B has a size of 5. And well, what does 5 look like? I don't know. It could be it's whatever we imagine it. I do know though that 5 is less than 8, and I know the other thing I know is that side A. Can this be side A? Here's my question. Can that be side A? The answer is no. That cannot be side A. Why not? Because side A has to be opposite angle A. This would have to be side A over here. This cannot be side A. So I'm going to, now I started to draw it. I'm going to take away that drawing. I will need to draw side A. But they also told us that side B is 5. I'm going to recommend that we draw side B up here, equals 5. The other possibility is not to draw it up there, but to draw it down here. This is the best place though. When you do these side angle things, this is the I would draw the 5 on top, and then I know that side 8 is bigger than. In other words, can I call this side A and label it 8? Does that look like a good idea? The answer should be no. That's not correct. It's smaller than what I drew there is much smaller than 5. It's important that you draw these somewhat accurately. And so side 8 is going to be quite a bit longer. Well, something longer. I'm going to kind of measure this out. I see my side 5 is about out to here if I do that. So it's reasonable that this would be size 8. Maybe it's reasonable enough. It's reasonable enough to give me a good idea of going back to the original question. Remember the original question. Do we have 1, 2, or 0 triangles with this information, with the information given down here? A is 8, B is 5, etc. Is that what we have? Okay, I can tell you right now there's no way we can get more than one triangle. I know that we have one triangle because this from this side of 5, this fixed angle of 20, the side of A equals 8 is going to reach this base level here. Now I haven't marked the length of that side. Looks like it's going to be a longer side than any of them. And that's going to be my triangle. This is fixed. I can't change that angle. We'll have to discover what this angle is. We'll have to discover what that angle is using the law of sines. That can be done. I know that this is side C, you know, and I know this is gamma, and I know this is beta down here, or, oh, they're using capital letters, so I'll use their convention here. Get that back. So they're calling this capital B. Let me kind of get that in there. And that would be little c, and this would be capital C. And so if you were going to use the law of sine to find these angles and the missing side, you could do that. Let me give you an idea. This is the case. I'm saying there's one triangle here, and it might help to see. And this is kind of the quick and dirty way. I'm not using the test of whether A is less than B and using H and you know, all the tests they have, and that, which is, I'll have to say, is the mathematically correct way of doing this. But you can get a good idea looking at this, and then you can prove it using law of sines, whether you have zero triangles, or and then you can also determine whether you have two or one triangle, as I'm saying we have here. Why am I so sure there's one triangle and I'm not using the you know, more rigorous method? Well, here's what two triangles would look like. Just give you an example, and I think that helps to understand this method. Two triangles. I know, for instance, if A equaled 4, and then the rest of the information was the same, B equals 5, A equals 20 degrees, I know we'd get two triangles. How do I know that? Let's get let me draw that out, and you'll see what I mean. I hope you'll see what I mean. Okay, so here's this picture again. Side A is no longer 8. And I don't have any of this information anymore. This is going to come back. Side A is 4 in this case. That means the side is shorter than the side B. Maybe I don't like the way I did. That's a little too short. It's a little too long. There we are. Something like that. That would be about 4. I know it's less than 5, and I know it appears to me that it's long enough to go from here to this bottom level. I could be wrong, but that'll come out when we do the law of sines. So I'm claiming that this is a case where there's two triangles. It's a little different information than we were given, but if I go over here and kind of separate the screen, and then let me put my thing in here again, my picture, kind of get another copy of it. Let me get rid of this extra stuff that we have. I know that this length of 4 here, I'm going to have to kind of make it less confusing. Get rid of that thing. I know that because this angle here is not fixed at the top, that 4 would also fit inside. Actually, it'd probably fit a little further inside. I'm going to have to clear this angle out of the way. It's kind of in the way. The 4 would fit inside like this. That's side A. This is still 20 degrees. I'm sneaking in here for side for angle A, and so that side of 4 is smaller than 5, and so to reach this level, it'll still fit in there. So, and I can also tell you that this angle here, this angle beta, or B, capital B, that angle there, that would be the first angle B, sub 1. This would be angle B sub 2. I have to put it outside here because we're kind of slim in there. That's B sub 2, because there's two triangles. I would have to call all these sides. This would be sub C sub 1. This would be C sub 2. Well, the side C, as you see, is much smaller over here. It's this guy. That's C sub 2. B is always 5, so I wouldn't call it B. I could call it B sub 1 and B sub 2. But they're both the same, and A is always 4 in each of these cases. But the pieces that are different are this angle beta, also this angle up here, capital C. That would be capital C sub 2. This would be capital C sub 1. Maybe I'll put little marks on my C to help differentiate it. Okay, so that's what's going on. This side 4 was able to pivot over the way it did, and it came inside. You know, if I draw it with an orange, you know, it pivoted. I didn't pivot it enough with my arrow, but it pivoted inside there. It can do that. Why can it do that? Because they didn't fix this angle. They did fix this angle. Angle A is I already have the angle marked. Is 20 degrees, and it's still 20 degrees on this one. Okay, let me bring out the case where there are 0 triangles. Let me shrink this up a little bit so I can get it all on the same screen. Okay, still, I think we can still see this. Okay, 0 triangles. No triangles. Maybe you can come up with the example that would have that. You're given B is 5. You're given angle A is 20 degrees. I'm going to draw my, bring that back in here. But they're not telling us what A is yet. I didn't mark what A is yet. That mess out of there. Okay. How long should I make this side such that there's no triangles? What does no triangles mean? Well, I'll tell you what. If I put A equaled 1, that means, you know, if this is 5, 1 is going to be this little, you know, section here. And that would be the length of side A. And because this angle is fixed at 20, angle A is fixed at 20 degrees, A equals 1 doesn't reach the ground. It can't reach down here. It can't make it. If that angle was much slimmer, you know, something like this, then maybe we could get it to work. But they fixed that angle at 20 degrees. It's not that small. It's fixed. And so side A being equal to 1, it's just swinging back and around. And here's, I'll do this one with the law of sines, and you'll see that there is 0 triangles. The law of sines will show it, and then put the equal sign in there. Okay, so in other words, if we know that sine of 20 degrees is to side A, that's the sine of angle A to side A, that's 1, as sine of beta, that's our unknown, or they're using capital letters, and they call it sine B, angle B, is to side of length 5, because that's what B is equal to, using the law of sines. We cross multiply, we'll see that sine B is equal to 5 times sine 20 when I cross multiply. Let's see if I can bring that information up so I can get it all on the screen here. Okay, watch what happens. We're going to use the calculator while I have some information in there. We're going to use the calculator. 20 degrees sine of, and then times 5. So I'm doing 5 times the sine of 20. That's the way I kind of have to do it backwards with this calculator, but that's the way it works. Comes out to 1.7 something, 7101 if we're using 4 decimal places. Sine B. That's impossible. Recall the angle, if you try to draw a sine curve, you recall that it doesn't get bigger than 1. The value of the sine of beta never hits higher than 1 or lower than minus 1. So, no triangle possible. No triangles. So, that's it. That's a way that you can draw these and find out how many triangles are possible. I didn't solve these first 2 triangles. I didn't find out what the angles were. I could go ahead and do that using the process I did down here, this law of sines. But this video is just to determine whether there's 1, 2, or 3 not 3, 1, 2, or 0 triangles, and that's a nice way of doing it.